Okay, here we go. Great. Today we are starting the product rule. So this is what we're doing this week. We're doing product rule, quotient rule, we're doing composition and chain rule next week, and then we have Thanksgiving break. So
when are we doing integrals?
Great question. We are not doing those until next semester.
Oh, yeah. Goodness.
We will do that, but we have a lot of derivatives to talk about before we can do integrals. Yeah.
I saw those on the thing, like later in the book, and they not in the book.
Yeah. I need to build out the topics. I could do that. I know what topics we'll do this week.
Terrifying.
Integrals look terrifying?
Yeah.
Actually, integrals are so much fun. Okay.
Oh.
So here we go. I have in here what you're doing. You'll do, so tomorrow you can finish the take-home portion of the exam if you don't already have it done. There will be a video from Flip Math, and also I'll collect homework 7 on Wednesday. Any homework questions that you want to go through right now? Homework 7, I think that's basically the trig functions. Okay, great. I have to post this stuff on Google Classroom still, but I'm going to do that after I finish teaching 6th grade, so it'll be on there before we leave school. Okay, great. And then, oops, this stuff I mean. And then on Thursday there's some things. Next week you'll have some stuff, blah, blah, blah. And then I'm trying to figure out what we're going to do with this Monday. Maybe we'll do another exam. I don't think that's worth doing actually. So I think probably what we're gonna do is probably push up implicit functions to this Friday and do implicit functions and implicit differentiation between this Friday and Monday and this week. It's probably what we're gonna do.
Yeah, let's not do another exam. I don't know if my grade can suffer that much.
Like trauma or something.
Need to let it rest a little bit.
I think you suffered worse than your grade will.
Yeah.
Yes, that's definitely true. Alright. Okay, great. I think that's all I needed to highlight here. And then
I should have taken like ADHD meds before I took the test or something.
Maybe it would help.
no, I think you just psyched yourself out. I don't like.
I did.
You knew how to do all of the things, and then
So
left them
bad.
blank. So I just don't know.
I got to that test and I was like, everything in my brain went out the door.
Yeah, I really think that was a flip. I think you're gonna be fine. But that's exactly why we need to do them, is so that doesn't happen for the first time on the AP exam. Because if that happens for the first time here, you're fine. So that's why we gotta do it.
Oh, it's so bad if that happened.
That would be really bad.
I think I just started crying.
So that's why I had us doing it.
I just started crying.
Okay, here we go.
You did that happens in exam halls where they taught us?
Oh,
Where
probably.
the kids just start
The
crying.
kid just like burst into tears.
That would be me, Loki.
That's gotta happen.
Well, Michael, I have notes for you, but sadly, you're not here. Well, I hope you feel better and that we see you soon. Okay, so here we go. Product rule is what we are doing today. So far, we have taken derivatives of sums and things that are with a constant multiple. Okay, so let me grab my pen. I'm like so not set up. So when we have functions added together, we can take the derivative of each function or each term, and we know how to do that. That is usually easy, especially now that we know how to take the derivatives of exponentials, trig functions, and polynomials. We have all of those tools on our belt, so it's easy to take derivatives of sums. So if I gave you any sort of function, if I give you f of x equals 3x to the 5th power plus sine x minus e to the x plus 2 to the x. We could take the derivative of each of these functions, no problem. And we could find the derivative of this. But notice that they're all added together. I mean, you could argue this is subtraction, but that's really just adding the opposite. So this is adding a negative, so we're just taking the derivative of sums. We've also taken derivatives of things with a constant multiple, so if I had some other function like 3e to the x plus 7 sine x, whatever, these constant multiples in the front don't matter. They just go along for the ride. And so those are also easy derivatives for us to take at this point. But what happens if we have functions that are multiplied together? Or what if we have functions that are divided by each other? Or even worse, what if we had a function inside of a function? What do we do? Cry, panic, give up. No. But actually, yeah, never mind. I'm not gonna. So if
Is this story?
no, I was just gonna say that we do a memory work about that in other classes. But okay. About not crying. About not doing that. The memory goes, what should you do when a problem is difficult? Work patiently, try different approaches, and do not give up. You know more than you think you know. Giving up on God's work when we face vexing intellectual challenges is not loving God with all our minds. So 7th grade has that. Algebra is working on it. 6th grade will do it soon.
I think we need that one.
I think we might need to do that one. We might need to do that one. Okay. So when we have all of these sums or constant multiples, it's easy for us to see why we can just take each part individually because, oh, this 7 will just factor out of my difference quotient when I plug that in. That's why it just goes along for the ride. Or if you plugged in this whole thing into the difference quotient, you'd end up factoring it all out, and you would see that each term is independent of the h. So that's why we can just take the derivative of each one. The problem is when I have something multiplied together, this has an x, and so does this. So then I can't just, well, I don't know, maybe I could, you know? What do we do with it? I don't know. What can or can't I do? So knowing how to take the derivative of something multiplied, of functions multiplied together, functions divided by each other, or functions smashed inside of each other, we need to have those tools in our belt, because believe me, these come up all the time, especially in real life. So let's just start with multiply together, which is what we are going to learn today is the product rule. What happens with derivatives when we have two functions multiplied together? Why don't you take a guess? What do you think? If I have two functions, f and g, multiplied together, what would you guess is the derivative of these?
This is a total shot in the dark.
Great.
But would you like split up each function? So you have f of x and then g of x. Would you just split it up and then write it as if it was like multiplied? Yeah, like that. And just take the derivatives of those two functions?
Okay, so if we just take the derivative of each one and then multiply those. Great.
Maybe.
Maybe. Let's try it. Okay, let's prove that this is actually not true. To prove this, no, that's exactly the guess I wanted you guys to make. That's exactly the guess I wanted you to make because I want to show you that that is not how it works. So naturally you would think, oh, I just take the derivative of each term. Great. Maybe that would work the same with multiplication. It doesn't, but I wanted you to guess that. I wanted you to think that because I wanted you to think, well, maybe it could be, but then to see why it's not. So to prove that this is not true, I'm going to give you two specific functions, and we're going to try it this way, and we're going to try it this way to see if they can be the same. So they won't be. Okay, so I'll give you f of x equals x squared, and I'll give you g of x equals 3x to the third plus 1. So first, let's take what f times g is. We can just find out what f times g is. So we'll just simply multiply together.
Oh, that brings me back.
You guys know this?
Yeah,
What is it?
it's grammar songs.
Grammar songs. Wild. Okay, so then what would derivative of f times g be? Because we want to see what's the derivative of this and see if it's going to be equal to the derivative of these. So what does derivative of this make?
15x to the fourth plus 2x.
Right. Okay, so we have our first one. So we have this. We know what this is. There it is. Let's find the derivative of f and the derivative of g, and then multiply them. Michael, I want you to email me if you can hear these songs in the video. So what's f prime?
2x.
Okay, g prime?
9x squared.
So then multiplying those together. What does that make?
Cubed.
Okay, so then we want to know, is 18x cubed equal to 15x to the fourth plus 2x? No. Not equal. So we know that because we have found one example where it doesn't work, then this rule, this guess right here, isn't going to work because it doesn't work for at least one example.
Yeah.
Definitely isn't going to work for the rest of them, okay? There actually are some functions that do follow that actually, but I'll leave those to you to find them if you want to. Okay, so we know that that's not going to equal, so what then? Here is what we call the product rule. I should have written some of this out in advance, but here you go, product rule. It's talking math curriculum, didn't have time. I haven't memorized it, I don't know. There is, I guess probably that would be better, but this is a little bit shorter. Okay, so There you go. There is the product rule. If you have two functions multiplied together and you want to find their derivative, then you take the derivative of the first one times g left alone, plus the derivative, plus the first one left alone times the derivative of g. Notice that because addition is commutative, you could write this as this way. Because it doesn't matter what order you do that in. Addition is commutative. Now, I want you to do it this way because when we do the quotient rule on Wednesday, the order will matter. And this is more like what the order will be. So I want you to use this one. It also just makes more sense to go in order.
Yeah.
Because also, this implies that, actually I'll leave this on the screen. This implies that if I have more than two functions multiplied together, then this is how you would take the product rule derivative of those. So if you had, for whatever reason, 4 functions multiplied together, to find the derivative using our product rule, you would just take the derivative of the first multiplied by the other 3 left alone, plus the derivative of the second times the other 3 left alone, plus the derivative of the third times the others left alone, plus the derivative of the fourth times the others left alone. So it doesn't matter how many functions you have here, you could have all 26 letters of the alphabet inside of here, and you could find that derivative if you just use this general idea. That make sense?
Is there a way to do that faster or work around? Like we did with just one function?
What do you mean? Like with the...
Like, you know how when we take the derivative of one function, we can just use the power rule to make that simpler so we don't have to use the limit definition.
Right.
Is there a way we can do this faster rather than doing all that up?
Memorize that.
Unfortunately.
Yeah, this is the product rule. Like, this is what happens if you have 2 functions multiplied together. How do you take that derivative? This is the derivative. This is this, like, direct path. I could have asked you to put it into your limit definition, and then we could have discovered this, but this is the rule. So, every time you have those functions multiplied together, this is your shortcut. This is the fastest way.
That's a long shortcut.
But not necessarily, I mean, it's not that long.
Yeah.
I mean, no, because let's just do an example. This is not that long, really. Especially because you don't often have 4 to 5 functions multiplied together. You often only have 2, maybe 3 multiplied together. So derive this. X times e to the x. Okay, so notice I have 2 functions multiplied together. I have x is a function times e to the x is another function. So I could call this my f, and I can call this my g, and then I just have to find the derivative of f and the derivative of g, and then plug those things into my product rule. So if f of x is x, then what is f prime of x? 1. And g of x is e to the x, then g prime of x is
E to the x.
also e to the x. So now we just take our pieces, we've organized our information, we take our pieces and we just plug it into the product rule. So this would say that h prime of x would be equal to f prime times g plus f times g prime is our product rule. So now we just take these pieces and plug them in. So f prime is 1. G is e to the x. F is x. And g prime is e to the x. And so we're just plug the pieces in. It's actually fairly mindless because you've already organized your functions and your derivatives. You just have to plug in those functions back into your product rule now that you have this organized. And then we can simplify this a little bit. What's 1 times anything? Right, and then I don't really need the parentheses over here because I can just drop those, so then there you go. And so there's the derivative, there's h prime x of, originally, x times e to the x. So there was our original, and there's the derivative. So I have these multiplied together. What on earth am I supposed to do? I can't just product rule this. I can't just power rule this, and I can't just take the derivative of e to the x because I have this x in the front. So then now my product rule helps because I have 2 functions multiplied together, and there you go.
That seems to be like different than what you did up top with the f of x is x squared, because with that one, it seemed to me that you were just multiplying the 2 base functions together instead of their derivatives.
Right here?
Yeah.
Yeah, because we were investigating whether the derivative of f times g is equal to the derivative of f times the derivative of g. So we first needed to take f times g itself to find its derivative to plug in here.
Oh.
Does that make sense?
Mm-hmm.
So this was an exploration just to prove that this is not how it works.
Okay.
This is why we need this in green,
Mm-hmm.
is because the pink doesn't work. That makes sense? Yeah. Okay, great. So here we are. We have h prime of x. Find h double prime of x.
You would just add another e to the x.
Are you sure?
Yeah.
You've already done it?
Yeah.
Okay, so we're going to derive h prime x. So,
H double prime of x.
yeah, but I want to derive h prime,
Oh, yeah.
which means I'll
Yeah.
get h double prime. Right, yeah. So, h double prime, notice that I have a sum. So I need to take the derivative of this term, and then separately take the derivative of this term, because I'm just adding these two. So our sum rule is still important from at the top of this page where we talked about just taking the derivative of each term. So this I can take the derivative of and just leave it. And then I can take the derivative of the other term, which I'll need the product rule for. So what's the derivative of e to the x? Just be e to the x, right? Plus, what is the derivative of x times e to the x? Well, we need to use our product rule. So we could call this f, we can call this g, we can find the derivative of those, we can plug them all in. Or we can see that, oh, this is the function that we already took the derivative of. What is the derivative of x times e to the x?
E to the x plus x e to the x.
Right. Make sense, gentlemen?
Mm-hmm.
Okay. So then this is the second derivative function. We are done. But we could rewrite some things if we wanted to. Because this is 2e to the x plus x e to the x. We'll just combine those. So we could simplify. Okay, so now go ahead and take 5 minutes. You guys can work together or not. Find h3x, fourth derivative of h, the 20th derivative of h, and the 100th derivative of h. Should have set this all up because now I'm getting sloppy with my writing. I'm gonna start setting up the next one. What's crazy is that's a real life example because she always asked me to go to the bathroom during math class. Okay, so what is the third derivative of h?
3e to the x plus x e to the x.
What is fourth derivative?
4e to the x plus x to the x.
Yeah, so this one definitely has a pattern. So this one's super easy. Not all derivatives work this way with the product rule, but this one has a nice pattern. So then we know obviously this will be
20.
Yep.
I like this one. We should do these ones.
Yeah, so these ones are super
It's
easy.
just a pattern.
Yeah, this one has a really nice pattern. Okay? But we won't always have that scenario. So here you go. Derive. There you go. Sine of x times x squared. So we'll definitely start by identifying that there's your f, there's your g, and you can name these whatever you want. You can call that a, call that b, call that u, call that v, whatever you want. But there's your first function, there's your second one. And so then off to the side, you can write down your notes of what each part of the product rule will be. And then put the pieces together. Got it?
Mm-hmm.
What do we got? Jonah?
Cosine x squared.
Cosine x squared.
Oh wait, I did backwards. No. Cosine 2x.
Cosine of 2x.
Wait a minute, no. I had it right the first time. I'm getting tripped up here.
I'm more pushing back on what you're verbally telling me. I'm writing exactly what you're telling me.
Hold on. Cosine x squared, right? And then plus sine 2x.
That's what you just told me.
Yeah. And then you'd have to. Hold up. No. I gotta go farther than that. That's not.
Take the second derivative. So, alright, Donna,
Yeah.
bear with me then. So, the formula for product rule is f prime times g plus
Yeah.
f times g prime.
I know.
So we could write it like this. We could say, here's f. So we could say the derivative of f times g plus f times the derivative of g. Yes?
Yeah.
Okay.
The derivative of g is just 2x.
Okay, so let's just go one term at a time. Derivative of sine x,
Cosine x
cosine x
x
times
squared
x squared plus
sine times
sine of x
x squared.
times
Or sorry, 2x.
2x. And there you go. Now you're done. Does that make sense?
Oh, yeah. So I just left off the.
You left off the argument for these and put this into the argument.
Yeah.
But this
Okay.
is a function. Like this. There you go. That can't. Those don't combine. Does that make sense? This x is tucked away inside the cosine function.
Okay.
So this x times this x squared isn't going to combine for whatever reason, you know?
Yeah. I left that off.
So that's why like writing these out piece by piece, detail by detail will help and will be really important so that you don't miss things. So either writing a list of the pieces that you have and then plugging them in, or writing it like this, where I take the derivative of this times my g and then simplifying those derivatives is also a good way to do it. Okay, so then there you go. We could factor out an x. We could do stuff algebraically. We don't need to. Just stop once you have the derivative. This is the derivative function. We don't have to simplify it. So dy dx equals this. Okay? Okay, so let's take the second derivative. Say example 5, I think. Derive the second derivative of this. And even notice that you have 2x times cosine x, 2x times cosine x. So you actually have two of those. So like you could combine those.
Yeah.
Again, do you have to? No, because what you found is correct. But I'll talk more about that when Jonas caught up.
So you can combine. You're done by 2. Just put number. Where do I get it?
Yes, you can put the 2 in the front, but you shouldn't have just a 2.
Right.
Okay, let's work through this one. Okay, you're looking at it. So I want second derivative of y. So here, now this is kind of an example where you kind of have an ABCD situation, but A, B, C, D are all multiplied together, you just have two product rules. You have product rule here and product rule here. If I want to take the derivative of this term, then I'll need to do the product rule for these functions. And if I want to take the derivative of this term, I'll take the product rule of these. Does that make sense? So we could call this, oh, she's different color. We could call this like A, and this B, and this C, and this D if we want to. So A is cosine X. So A prime is, okay, B of X is X squared, so B prime X is C is sine X, and D is 2X, and D is 2X. So C prime and B prime. Okay, so we have all those details. Listen up. Now we're just plugging in, because if we have this product rule, we're going to have the derivative of A times B plus A times the derivative of B for this, plus the product rule of these two, so that will be C prime D plus C D prime. Okay, now that we have that laid out, we are just going to plug the pieces in. So we have second derivative of y is A prime. All right, A prime is negative sine X. Okay, B, X squared. All right, plus A cosine X times B prime is 2X. Okay, Jonah, can you talk me through the rest?
And then you would have the cosine plus cosine X
Cosine X
times 2X
times 2X
plus sine of X times 2.
times what? 2. There you go. You're done. But now I want to talk about this, because you could stop here and you are correct. That is a correct derivative, second derivative of originally ry. Okay, so this is a correct second derivative. You don't have to simplify any further. That being said, on the AP exam, if you're doing a multiple choice question and they ask you to take the product rule of some function, they're probably not going to have the multiple choice answer like this. They're probably going to ask you to algebraically manipulate this into some kind of multiple choice answer. So notice that we have these two terms here are exactly the same. Cosine X times 2X, cosine X times 2X. So I have two of those. So I could rewrite this as 2 cosine X 2X terms plus the negative sine X squared term plus the sine X times 2 term. So maybe the multiple choice would look something like that. Maybe you could even see that you could just simplify this 2 here, and so you really have 4x cosine X plus, well, then you could just do minus sine X squared plus 2 sine X. I mean, this is all just like, we're just moving pieces around algebraically. This is no calculus at all. We're just manipulating this because maybe the multiple choice answer looks different, you know? Okay, you could look and see that these have a sign in common, so you could even factor out the sine of X. So you could have 4x cosine X. Let's see, probably minus sine X times X squared minus 2. don't think we could really factor anything else out here, but like we could have done other things. We could have pulled this 2 out to the front. Like there's a lot of things you can push and pull and move around algebraically. So if you get this derivative, it's not that, and then you don't see this on the multiple choice, it's not that you're wrong. It's that you probably just need to move pieces around until it looks like one of your multiple choice answers. It would probably look something closer to this one here as your answer. Does that make sense? So you did the hard part with the calculus, and then from there, it's algebra. You're just moving pieces around until you get to whatever the answer would be. Okay? And we could have done that with a lot of our other ones up above too, but okay, let's do this one. Let's see if we have enough time to do it. Do I want to do this one instead? Nope, I want to show you this because I think this will be more helpful. So this is probably the last one that we'll get to, and hopefully we can finish it. But I want you to derive this 2 ways. Derive 2 ways. F of x equals x to the 4th plus 3x squared times 5x to the 3rd, it's really bad 5, minus 7x squared. Whew. Okay, these are big. These are beefy binomials here. But we've got this. There's 2 ways you can do it. First, you could obviously do the product rule, right? You have one function times another function. So you could just do the product rule. Or you also could FOIL this out as it is, and then notice that you would just have a polynomial. And we could just use power rule. I want you to do it both ways. You can pick whichever one you want to do first, but but it'll make my point very clear. Okay, so I put all the work here. If you FOIL this first, then you get these 4 terms, and then you take the derivative of those 4 using power rule. Done.
Yep.
If you use the product rule, because you're like, oh look, I have a function times a function, I should use the product rule. Great, you can do it, totally fine. Here's your f prime, g, and g prime. So then you just plug in your pieces. Here's f prime times g. Here's f times g prime. Then you can FOIL this out, FOIL this out. You've already taken the derivative by putting in the product rule. So then now you just have to simplify all this algebraically. Really, you are done. This is a true derivative. But to show you, if you simplify algebraically, you get all 8 of these terms here. If you combine them, you've got 20 and 15 sixes, so that's 35. You've got minus 28 minus another 14 is negative 42 of the fifth. You've got 30 plus 45 of the fourth. You've got minus 42 minus 42 of the thirds. There you go. So there's all that work if you use it, if you FOIL out the algebra after you take the product rule. Again, could you stop right here? You could stop right there. That's no problem. Either way, you find a true derivative, and really, this box right here and this box right here are exactly the same formula. One is just more simplified. And so, if you're on the AP exam and you're like, oh, for whatever reason, I can't remember the power rule, then probably your brain is broken, but also you could use the power rule.
That's what I'm talking about.
Then you could also use product rule. If for whatever reason you can remember product rule and you can't remember power rule, again, maybe you need help. But to show you, you get there either way. There's some flexibility. And so if you have a function times a function and they're polynomials, probably just use the power rule.
Yeah.
There's a lot of functions that you could just use power rule for, and there's no reason to do the product rule, even though they are multiplied together, because probably you can simplify and then derive. But notice that here in the original, these two are multiplied together. But when I actually then multiply them, now I just have 4 individual functions that are all added together. And so then that's why I can do the product rule. Okay? So don't do this. This is silly. Just use the power rule. Okay, but the product rule is super important for when we have like a trig function times a polynomial or an exponential function times a polynomial. We've got to use the product rule for those. And it's way easier to use product rule than trying to do some other crazy thing, which there's really not another thing to do other than the product rule. So that was pretty much all of our examples. There was only one left that I had for us to do, but that was probably because I was late. So anyways, great job. So on Wednesday, we'll do the quotient rule. What if functions are divided by one another? What do we do? So we will do that on Wednesday. And it is also, honestly, just as easy as plugging things in for the product rule. You should memorize the product rule, so memorize it. You will need it memorized. You will also need to eventually memorize quotient rule and the rule that we learn after that, which is called the chain rule. Okay. Great. Tomorrow you have a video to watch. That's what the packet's for. I want you to complete the problems in the packet as well. I'll check them on Wednesday. It'll all be on Google Classroom. That's your next class, Bill. So. Yeah, great. If you have any questions, email me. But I think you're gonna be all right.